Welcome to Sairam Triple YouTube channel. Let us discuss module 5 uh, power system unit commitment UC problems. The objectives of a function of the UC problems can be unit commitment problems formulated as the sum of the costs of all the units of overtime and presented mathematically mathematically actually. Uh, so the main objectives is solve the cost of all the units over time. So unit commitments, so like number of units we want to supply, or number of units we want to deliver. So some of the commitments will be there for this in the smart grid technologies. So ADP for optional network reconfiguration in the distribution automation. Case study for RER integration. Distribution network are generally configured readily for effective and non-complicated protection schemes under the normal operating conditions. Distribution feeders may be reconfigured to satisfy the objectives of minimum distribution line losses, optimum voltage profile, and overloading relief. Right? And test beds and benchmark system. So the development of computational tools for power system application requires extensive testing and validation for efficiency, speed, accuracy, reliability, and robustness. So challenges of smart grid smart transmission. Two key issues in the developing of smart transmission, like uh, developing the smart transmission grid. So challenges smart transmission in the sense of power supply from the generating station to the consumer side involves citing a decision and providing reasonable policies for equitable cost allocation in both cases. Um, Congressional response is needed that gives FERC authority to take bold and decisive actions. These challenges of smart grid smart transmission. Mm. So benefits of smart transmission. Smart transmission investment provides many benefits to power customers and electricity markets. Although they vary according to the type of the location of smart technologies. Installation of new digital technology. See, installation of new technology is needed because smart grid itself implementing or um, so updating the power system components, right? So implementation of the functionalities identified that this chapter or aimed at achieves: increase the reliability, ability to reliable the operation, increase the electricity throughout the lower delivered cost, and more efficient fuel usage, mm, generation yielding lower air emissions, greater use of RER and clean generation resources with a lower operational integration costs, more effective use of energy storage, reduce the cost of peak electricity provision, facilitate the third party participation in the power system. So foster wholesale retail market, improving the information available to customer and market participants about the grid connection, electricity prices and usages. So these are the benefits of smart transmission, because so electricity we are transmitting, if you are following age old methods, so there is a losses will be more, and then there is a drawback will be there, and then drop will be there. So if you implement this smart transmission, definitely the more advantages. It's a reliability will be there, increase the electricity throughout the lower delivered cost, and so increase the electricity because losses will be less. Definitely it's a more efficient fuel usage of for generation also, yielding lower air emissions. See, if you involve, I mean, implement a smart grid, definitely air emissions are even the generation side also smart grid implementing into solar and wind power plants, right? So it will not be harmful for the nature. So that's what it increases the efficiency of the for the generation also. Greater use of RER and clean and generation resources. I told you, right? Clean energy resources, clean, if you are generating electricity in the clean way, so definitely it's more efficient, right? So this is a concept. Once again, we'll revise uh, power system unit commitment and optimal network configuration distribution automation case study for RER integration. See, distribution automation is there. Automation, like if suppose, for example, I'll tell you, I mean distributed automation. If suppose power failure occurs in the one H pole mounted substation, what happens? Automatically the switch over to the other substation. I mean, like other transformer or other line, so directly it goes to the consumer side. So because without interrupting the power, I mean consumer side power supply. So that's what the smart grid I mean works here, and it's needed for the present power system components and power system analysis and smart grid technological concepts. Okay, just to consider. So the present power system is converted into smart grid, just implementing, just updating the power supplies, right? That's a concept.